Have you ever wondered what would happen if, one day, all those massive electric vehicle charging stations, thousands of charging points stretching from California to New York, from Houston to Chicago, suddenly became irrelevant overnight? Not because electric cars were banned, not because battery technology became outdated, but because someone had demonstrated that charging stations were no longer necessary, and that someone wasn't a flashy Silicon Valley startup or a tech billionaire dominating social media headlines. It was Honda Motor Company, a 75-year-old Japanese automaker known for its cautious approach, engineering discipline, and quiet innovation. Without any major announcement, red carpet event, or dramatic product launch, Honda's CEO reportedly entered a highly secure laboratory in Tochigi Prefecture, Japan. Inside the facility stood a single vehicle. There was no charging port, no power cable, no large lithium-ion battery pack. Instead, the vehicle featured a new generation hybrid power system capable of generating its own electricity while in operation. Just 48 hours after information about the project allegedly leaked, electric vehicle stocks experienced significant turbulence. Billions of dollars in market value disappeared. Tesla shares stumbled, Rivian dropped sharply, Panasonic came under pressure, and investors who had poured trillions into the future of full electrification suddenly began asking difficult questions. So what exactly happened inside that sealed laboratory? How does this technology work? Why did it send shockwaves through a trillion-dollar industry? Is this truly a historic turning point in automotive technology, or is it simply a strategic move by a major automaker trying to regain its competitive edge? More importantly, if this technology proves to be real and viable, what could it mean for you, the car you drive, and the future of global energy systems? To understand why the alleged leak from Tochigi generated so much attention, we first need to look at the bigger picture. Over the last decade, electric vehicles have become far more than just a transportation technology. They have evolved into political commitments, environmental strategies, and symbols of the transition toward a cleaner future. Governments around the world have invested enormous resources into accelerating EV adoption. In the United States, hundreds of billions of dollars have been directed toward charging infrastructure and clean energy initiatives. The European Union has announced plans to phase out new gasoline-powered vehicle sales by 2035. Numerous states and countries have established similar goals, while automakers such as General Motors, Ford, Volkswagen, and Hyundai have committed hundreds of billions of dollars to electrifying their product lineups. Yet beneath the optimism, several challenges continue to emerge. The first challenge is charging infrastructure. While charging networks are expanding rapidly, many public charging stations continue to face reliability issues. Drivers frequently encounter chargers that are out of service, overcrowded, or unavailable when needed. In many rural regions, charging stations remain widely spaced, making long-distance travel more complicated than expected. The second challenge involves the electrical grid itself. As millions of EV owners plug in their vehicles during peak evening hours, electricity demand rises dramatically. In states such as California, Texas, and Arizona, power grids already face significant strain during periods of extreme heat. Adding millions of additional vehicles to the network only increases the complexity of maintaining a stable energy supply. The third issue centers on battery materials. Modern EV batteries require large quantities of lithium, cobalt, nickel, and manganese. Much of the global supply originates from regions such as the Democratic Republic of Congo, Chile, Argentina, and China. This dependence raises concerns about environmental impact, labor practices, supply chain security, and geopolitical risks. Honda's engineers reportedly recognized these challenges long before they became mainstream discussion points, and that realization led to what may be one of the company's most ambitious research efforts. Project HX Prime. Honda's 17-year secret back in 2008. While much of the automotive world was celebrating the rise of lithium-ion batteries and the promise of fully electric vehicles, Honda quietly launched a long-term research initiative at its R&D facilities in Toigi Prefecture. The project was reportedly known as HX Prime. Its goal was not to create a better electric vehicle. Instead, Honda's engineers set out to solve a different problem entirely: how to build a vehicle that could operate with minimal dependence on external charging infrastructure. They believed the emerging EV revolution had a critical vulnerability: total reliance on outside power sources. While the rest of the industry focused on building larger batteries and expanding charging networks, Honda's researchers explored an alternative path: a vehicle capable of generating the electricity it needed while driving. If successful, such a system could fundamentally reshape the assumptions behind modern transportation and challenge one of the core pillars supporting today's electric vehicle ecosystem. And that possibility is precisely why the alleged developments from Toigi have attracted so much attention around the world. Electric vehicles depend on charging stations. Charging stations depend on the power grid, and the power grid depends on power plants. The entire system is interconnected, and any disruption at one point can affect everything else. More importantly, this model doesn't work equally well for everyone. Large portions of the world's population live outside major urban centers, where charging infrastructure remains limited or non-existent. That led Honda's engineers to ask a simple but revolutionary question: what if a vehicle could generate the electricity it needed while it was being driven? That question became the foundation of Project HX Prime. And according to the information that has surfaced, Honda may have found an answer. By 2012, the project had reportedly produced several working prototypes. Then, without warning, it seemed to disappear. There was no public announcement, no cancellation statement, no explanation from the company. On paper, Project HX Prime simply vanished. According to industry insiders, the project wasn't abandoned because the technology failed. Instead, it allegedly faced political and economic resistance from multiple directions. Major oil companies had little interest in a technology that could disrupt fuel consumption patterns. Emerging electric vehicle manufacturers were investing heavily in charging-based ecosystems. Even some of Honda's own battery and technology partners had concerns about a system that might reduce dependence on traditional battery infrastructure. At the same time, Honda was under increasing pressure to focus on other alternative energy projects, particularly hydrogen-powered vehicles such as the Clarity fuel cell. Hydrogen technology was widely viewed as a safer strategic direction because it posed less disruption to existing industries. As a result, the HX Prime prototypes were reportedly placed into storage inside a climate-controlled facility. The engineers moved on to other assignments. For more than a decade, the project remained largely forgotten. Then the landscape began to change. By 2024, the electric vehicle industry was facing growing challenges. News headlines highlighted battery fire incidents, strained electrical grids during periods of extreme weather, controversies surrounding lithium mining operations, and increasing consumer frustration over long charging times, especially in cold climates. The problem of range anxiety never fully disappeared. Instead, it evolved into a more complex set of concerns involving infrastructure, charging availability, and energy reliability. Honda saw an opportunity. In early 2025, company leadership reportedly made a bold decision: bring Project HX Prime back to life. Rather than starting over, engineers returned to the storage facility and recovered 3 prototypes that had remained untouched for nearly 13 years. Using modern electronics, advanced materials, and updated control systems, they upgraded the vehicles and returned them to testing within just 5 months. What happened next reportedly surprised even some of the engineers who had originally worked on the project. At first glance, it sounds like another story about an old concept being revived, but according to reports, the test results were extraordinary, and those numbers are what sparked so much attention. The engine many people didn't believe existed. So what exactly makes this system different? To understand that, it's important to begin with what it is not. This is not a conventional hybrid vehicle like the Honda Accord hybrid or Toyota Camry hybrid. Traditional hybrids use electric motors to support a gasoline engine, particularly during low-speed driving. Their batteries are recharged primarily through regenerative braking. They're efficient, but they still rely heavily on gasoline and have clear performance limitations. Nor is this a plug-in hybrid such as the Chevrolet Volt or Toyota RAV4 Prime. Those vehicles still require regular charging from an external power source to achieve their maximum efficiency and electric driving range. According to the reports, Honda's technology represents something different entirely, a self-regenerating hybrid system, sometimes described as a closed-loop hybrid design. The name reflects the core idea behind the technology. At the heart of the system is a component referred to as a thermal regenerative piezoelectric drive. The term sounds highly technical, but the basic concept is surprisingly straightforward. A traditional gasoline engine wastes a tremendous amount of energy. In many cases, as much as 60 to 70% of the fuel's energy is lost through heat, friction, vibration, and exhaust. That's why engine compartments become hot and exhaust systems release large amounts of thermal energy into the atmosphere. In simple terms, a significant portion of the fuel you pay for never contributes directly to moving the vehicle. Honda's reported solution was to capture some of that wasted energy and convert it into usable electricity while the vehicle is operating. Using a combination of thermal recovery systems, vibration harvesting technology, and pressure-based energy conversion, the vehicle continuously collects energy that would otherwise be lost. Heat from the engine, mechanical vibrations generated during movement, pressure produced by the exhaust system. All of these sources are converted into electrical energy and stored inside a compact supercapacitor system roughly the size of a small lunchbox. The result is a vehicle that requires no large lithium-ion battery pack, no external charging cable, and no dependence on public charging stations. The gasoline engine remains the primary source of power, but the hybrid system continuously recovers and reuses energy that would normally be wasted. And according to reports from the testing phase, the performance figures were impressive. Multiple sources claim the vehicle accelerated from 0 to 60 miles per hour in approximately 4.3 seconds. Faster than most current Honda models and competitive with many mid-range electric vehicles. Top speed reportedly reached around 180 kilometers per hour. Equally important, the vehicle maintained strong performance while climbing steep grades, avoiding the power loss that has affected some earlier hybrid designs. But perhaps the most surprising figure of all wasn't acceleration or top speed. It was the vehicle's driving range. According to the reported test results, the vehicle can travel up to 760 kilometers on a single tank of fuel. No charging stations, no waiting for batteries to recharge, no plugging in overnight, simply refuel in less than 3 minutes, just as drivers have done for decades, and continue the journey. Fuel efficiency is said to be around 5 liters per 100 kilometers, while the hybrid energy recovery system reduces fuel consumption by more than 40% compared to a conventional gasoline engine of similar performance. In theory, this addresses one of the biggest concerns surrounding electric vehicles: range anxiety. Drivers would no longer need to worry about finding a charger, planning routes around charging stations, or depending on an already stressed electrical grid. Even more impressive is the system's reported performance in extreme weather conditions. Unlike many lithium-ion batteries, which can suffer significant efficiency losses in freezing temperatures, this technology reportedly continues to operate normally at temperatures as low as -22 degrees Celsius. That's particularly important for drivers in regions that experience harsh winters, where battery-powered vehicles often face reduced range and longer charging times. Another detail drawing attention is emissions performance. Independent laboratory reports allegedly indicate that the vehicle produces extremely low emissions, with exhaust output consisting primarily of water vapor and heat under certain operating conditions. Reports claim minimal carbon dioxide emissions, virtually no nitrogen oxides, and no visible soot. If these figures prove accurate, or even close to accurate, Honda may have found a way to tackle three of the most persistent challenges facing modern electric vehicles: driving range, charging convenience, infrastructure dependence, and then there's the cost. The complete powertrain system is reportedly estimated to cost around $1,320, which is less than one-third the cost of many conventional electric vehicle drivetrains. Operating expenses are said to be approximately 0.8 cents per mile, significantly lower than the average operating cost of many electric vehicles and traditional gasoline-powered cars. According to projections, consumers could recover the additional purchase cost through fuel savings in roughly 1.4 years. If those numbers hold up under real-world conditions, this wouldn't simply represent an incremental improvement. It would represent a major economic disruption to the automotive industry. The challenges behind the headlines. However, no technology is without limitations. And while the headline figures may sound revolutionary, the real story becomes far more complicated when we examine the obstacles standing in the way. The first challenge is manufacturing. The system reportedly relies on specialized corrosion-resistant alloys and advanced piezoelectric materials designed to convert mechanical vibrations into usable electrical energy. These materials are not particularly rare, but they are not widely used within today's automotive supply chains either. As a result, industry estimates suggest initial production costs could be around 15% higher than those of a conventional hybrid system. That doesn't make mass production impossible, but it does mean scaling up manufacturing would take time and significant investment. The second challenge involves intellectual property and regulation. Honda reportedly filed a patent application related to the technology in Japan in 2023 before later withdrawing it. Some legal analysts believe this may have been a deliberate strategy to protect sensitive engineering details from becoming publicly accessible through patent disclosures. While such a move could help preserve trade secrets, it also creates uncertainty regarding future intellectual property protections and ownership disputes. The third challenge may be even more significant: resistance from competing interests. According to reports, shortly after information about the project became public, lobbying groups in Europe began encouraging regulators to reassess how advanced hybrid systems are classified under environmental standards. If regulations change, technologies currently considered clean or low emission could face entirely new requirements. In the United States, some industry representatives reportedly dismissed the claims as little more than a publicity campaign. At the same time, reports suggested that policymakers were discussing potential taxation frameworks related to highly efficient propulsion technologies. The idea sounds almost unbelievable. A vehicle could potentially face additional taxes simply because it consumes too little fuel. Whether such proposals ever become reality remains uncertain, but the discussion highlights the economic interests that could be affected by a major technological breakthrough. Who will emerge as the winner, and who stands to lose the most? One of the most intriguing reactions came from Tesla, arguably the most recognizable electric vehicle company in the world. The response wasn't a public statement or a technical rebuttal. It was silence. A noticeable silence. Elon Musk, known for commenting on everything from technology and artificial intelligence to politics and cryptocurrency, did not publicly address Honda's reported breakthrough. No posts, no interviews, and no direct response. Adding to the speculation, reports suggested that planned upgrades to the Cybertruck production line were temporarily paused for internal review. Whether related or not, the timing caught the attention of industry observers. For companies like Rivian and Lucid, the stakes could be even higher. Both manufacturers have spent years investing heavily in scaling production while continuing to operate at significant financial losses. If a new technology can deliver comparable performance at a substantially lower cost, it could place enormous pressure on their business models. General Motors and Ford face a different challenge. Over the past decade, both companies have invested tens of billions of dollars in electric vehicle development, battery production, and charging infrastructure. Yet unlike many newer EV companies, they also possess decades of expertise in traditional engine technologies and hybrid systems. If self-regenerating hybrid vehicles were to gain widespread acceptance, these legacy automakers would likely have the technical capability to adapt more quickly than companies focused exclusively on battery electric vehicles. The real question is whether they would be willing to shift direction after investing so heavily in an electrified future that has yet to deliver the profitability many expected. Meanwhile, South Korean manufacturers Hyundai and Kia are watching developments closely. Both companies have built highly competitive electric vehicle portfolios while maintaining strong capabilities in hybrid technology. That balance could prove to be a significant advantage if the market begins favoring alternative solutions between conventional gasoline vehicles and fully electric cars. Japan may also find itself in a favorable position. For decades, Japanese automakers have been leaders in hybrid technology. Toyota, Honda's longtime rival, transformed the industry with the Prius and helped establish hybrids as a mainstream automotive category. If consumers begin embracing advanced hybrid systems as a practical middle ground solution, Japan's automotive sector could be well positioned to benefit. China faces a more complicated situation. The country has spent years building the world's largest electric vehicle ecosystem, supported by extensive battery manufacturing capabilities and a highly integrated supply chain. Companies such as BYD and numerous emerging EV brands have helped China become a dominant force in the global electric vehicle market. But if future transportation trends shift toward technologies that reduce dependence on large battery packs, some of that strategic advantage could be weakened. Then there are the consumers themselves. For many drivers, particularly middle-aged and older generations, the appeal of a vehicle that doesn't require charging stations could be incredibly powerful. Millions of people still view refueling with gasoline as simple, familiar, and convenient. Many remain concerned about charging availability during long-distance travel or in areas where charging infrastructure remains limited. A vehicle capable of traveling nearly 800 kilometers on a single tank, refueling in just a few minutes, and operating without any specialized charging network would likely attract significant interest. For many drivers, it could offer the best aspects of both worlds. There is a very real possibility that governments may eventually adjust regulations to protect the investments they have already made in electric vehicle infrastructure and related industries, regardless of whether a new technology ultimately proves to be more practical, efficient, or environmentally beneficial. According to reports, Honda is preparing to formally unveil this technology at an upcoming Tokyo Auto Show, and if the reports are accurate, it won't be presented as a futuristic concept or experimental prototype. It will be accompanied by a genuine production roadmap. The company's initial rollout strategy is said to focus on regions such as Asia and the Middle East, where charging infrastructure remains relatively limited and demand for practical transportation solutions is particularly strong. If those launches prove successful, expansion into North America would likely be the next major step. Internal projections reportedly target production of up to 1 million engines annually by 2027. If Honda achieves that goal, this story will become much bigger than the launch of a new vehicle. It could become a story about how a single engineering breakthrough, developed quietly behind closed doors in Japan, ended up influencing global energy markets, international economic competition, and the daily transportation choices of millions of people around the world. The questions that remain. What happens next may determine the future direction of the automotive industry. Can Honda successfully mass-produce the technology at the scale it has suggested? Will regulators embrace it, challenge it, or attempt to reshape the rules around it? How will established automakers respond? And perhaps most importantly, does this represent the end of the electric vehicle boom as we know it, or simply the next stage in the evolution of transportation technology? The answers remain unclear, but one thing is certain. The coming years could bring some of the most significant changes the automotive industry has seen in generations. Your turn now. We'd like to hear your perspective. Do you believe a self-regenerating hybrid system like this is technically possible? Or do you think the story has been exaggerated beyond what the technology can realistically achieve? And if a vehicle with these capabilities became available tomorrow, would you consider buying one? Share your thoughts in the comments. Different viewpoints make conversations like this far more interesting. If this analysis gave you a new perspective on the future of transportation and the competition shaping the automotive industry, consider supporting the video with a like. And if you'd like to stay updated as more official information emerges and this story continues to develop, be sure to subscribe. Because one thing is clear, this story is far from over, and the next chapter may be the most important one yet.